Okay, so let's start with the Hadoop architecture, that is 2.x for today. Okay, so we'll try to take the same concepts like yesterday. A few things will change and let's understand those few things. Okay, so the first thing is in Hadoop 2.x, the block size is 128 MB. Okay, so in Hadoop 1.x, we had a block size of 64 MB. So that is one small change. Replication factor. Again, the replication factor from my 1.x to 2.x is same. So there is no change in my replication factor. So the replication factor remains the same. Okay. So the block size is 128 MB and the replication factor is 3. We'll try to take the same scenario like yesterday, how we took the name nodes and data nodes and the clients. Same way we'll try to take today also. So this would be my client. And let's say these are my data nodes. Okay, so 1 2 3 4, I'll take a 6 node data cluster. So now here yesterday we had a name node, right? Okay, so here we will be having one more extra node. I'll tell you what is that node. Okay, so I'll just draw the diagram so that it would be pretty easy for me to do the things quickly. So let's say this is my client, or it is like edge node. Okay, this is nothing but my active name node. Okay, this is nothing but my standby name node. So this is the new node which is come into picture today in the architecture of my 2.x. So that is nothing but my standby name node. Okay, and this is nothing but my same node which we have yesterday. So that is nothing but the secondary name node. These are nothing but my data nodes like yesterday. So this is, let's say this is my data node 1. Let's say this is my data node 2. Let's say this is my data node 3. And let's say this is my data node 4. Hopefully we are able to recall the same concepts. Okay, now how the interaction goes, like when the request is being sent from the client to the active name node. Okay, we'll come to the question why it is active, why it is standby slowly as we progress. As of now, let's go with the basic understanding. Okay, so the client is sending the request. So what is the job of name node? To manage the metadata and to manage the cluster. Okay, now once the name node identifies, and there is one small difference in 1.x architecture and 2.x architecture, and the difference is the data nodes here. Okay, if you see, the data nodes here will be sending the heartbeat. I hope we now understand the heartbeat, so I'll not be explaining that. So the data nodes send the heartbeat to your active name node. Okay, after every 3 seconds. So that is the time limit. Okay, so what happens after every 3 seconds, your data node sends the heartbeat to your active name node. Simultaneously they are connected. Okay, not sending the heartbeat, I'm just telling connected, or they are connected to the standby name node also. Okay, so after every 3 seconds they are sending the heartbeat like yesterday. So where they are sending the heartbeat, they are sending the heartbeat to active name node. Okay, now out of the two connected, so if you see, all my 4 data nodes are connected to my active name node as well as my standby name node. Okay, but they are only sending the heartbeat to the active name node. Okay, so how the data node comes to know this is an active name node? Okay, again there is a concept, will come into the picture slowly. Now let's take a scenario. Yesterday we took a 100 MB file. Okay. Today we'll try to expand that and we'll try to take a 200 MB file. Okay. The reason being is, as we have a, so I'm getting a 200 MB file because now my block size is 128 MB. So just to make a meaningful example, what I'm trying to do is I'm trying to take a block size of my I'm trying to take a file which is of my 200 MB. Okay. Now once this file is coming in my Hadoop 2.x architecture, okay, so this file will be broken into two chunks. Okay. So this file will be broken into two chunks, and what are those two chunks? Of one will be of 128 MB. Okay. So let's take, so let me write this over here. So one file would be one block would be of my 128 MB because that's the minimum block size, and the second is the remaining part of my file, which comes to 72 MB. Okay. So this is how my file is broken. As we have seen yesterday, what we have seen yesterday? So what we have seen yesterday is blocks are written in parallel. Okay, that's what we have seen. And the second thing what we have seen is, replication is done sequentially. So the same thing will happen here also. Okay, how? So let's say this is my one, not here, let me just take this over here. So let's say not here as well, let me draw it over here. So let's say this is a block and that is of 128 MB. So I'm just trying to fill that with some color. Okay, and let me take that. So how the distribution will happen, how the blocks would be written? So it would be written in parallel. So let me take, this is my first block. Okay, so there will be no space, I'll just be writing out if it is coming into the same node. Okay, and let's say the 72 MB is of color, and that color is, let's say we'll try to take the blue color and let's try to fill that as well. Okay, and let me try to crop it. So once this are being successfully written in parallel, then your replication starts. Okay, so let's say, let me just take this, Control C and V. So it is writing over here, it is writing over here, same like yesterday. And let me just take over here. So it could be a scenario like, so just consider this is under this data node, so I don't have space, so I'm just trying to take it out. Okay, let me hide this. Now the blocks are written parallelly as well as my replication is done sequentially. So the data nodes are sending the heartbeat to the active name node. Okay, and after every 3 seconds the heartbeat is sent to the active name node. There is a person who's that person, a standby name node. Okay, he's that person. So there my data nodes are simultaneously also connected to my standby name node. Okay, now let's see the differences or the additions in 2.x architecture. Now if you see, out of the two nodes, one is active and the other is standby, and all my data nodes are connected to these data name nodes. How my data nodes are coming, which one is active and which one is my name node, which one is my standby node. Okay, so there is a concept, or there is one file, and that file is nothing but a file which says there is a file which is nothing but a file which is name. Let me just make it a black color and let me write that again. So there is a file which is nothing but in_use.log file. Okay, so this file, whichever name node or standby node is having, that is considered as an active. Okay, so as of now, this in underscore use log is available with active name node. Hence, active name node is considered as my, this name node is considered as an active name node, and all my data nodes are sending the heartbeat to my active name node with the help of in underscore use log. Okay, so this is the file which tells the data node you need to send a heartbeat to this person or this name node. Okay, now there comes a question: if there are two name nodes, who decides which will be having in underscore use log? Okay, so if we take an example of, let's say, a team leader like we took yesterday. A team leader has 5 resources, so all the 5 resources are sending the whatever the work they are doing or reporting to the team leaders. Okay, so now if what in the extra thing, they have brought 2 team leaders. So one is actively working and one is standby. So he's working on this other project, but if this person is not available, he'll be taking up that charge. So the same concept comes over here. So standby name node. Okay, but there should be some person who should instruct the standby name node if this person is not available. Okay, so that person is nothing but that person's name is zookeeper. Okay, so what that person's name is? That person's name is zookeeper. So what he does is he manages all your name nodes. Okay, so the same way like how your name node manages your data nodes, so your team leaders are managed by your manager, and that manager is zookeeper. So zookeeper will be managing all the name nodes. Okay, so before going to that concepts, let's come back a little bit. So we have now we know a little bit. Okay, so zookeeper is assigning the in underscore use log. How it is assigning, with what concept, we'll try to see. But as of now, we just got to know, okay, there is a file which is in underscore use dot log file. Whichever name node has that file, that is considered to be as an active name node. Right, cool. So remember yesterday we had seen a concept called fs image and edit logs, right? Okay, now here there is a small difference. Okay, and what that difference is, let me just erase this because I need to have certain space, and let me just crop this and take a little bit up. Okay, and let me just draw that back again. So let's say this is my zookeeper. Okay, now there is one more person. Okay, and that person name is journal node. What that person name is? Journal node. What this journal node does is, in this journal node, your edit logs are kept. Remember yesterday we were having our edit logs and fs image in your name node only. So let me just write this. So this is will be having your edit logs. Okay, so who will be having your edit logs now? Journal node will be having. Okay, so when you're active, and here you will be having your fs image. So like yesterday, same thing, no change in that. Here also it will be having fs image. Here also will be having your fs image, and definitely your secondary name node will also be having the fs image. Okay, so what happens is, when your active name node and your standby name node, so the edit logs are there. So whenever the request is sent by the client, so the name node work is to manage the cluster and manage the metadata. So what your name node does is, okay, so what your name node does is, it tries to send. So if you see, the edit logs are there. So when they are writing the fs image, at the same time they need to write the edit logs. So what active name node will do? So it will write whatever the request which is sent by the client, it will write that metadata information in fs image and the edit logs. Okay, so what active name node would be doing is, it would be writing the information. At the same time, At the same time, what your standby name node would be doing is, it would be reading it. So at a given moment of time, so this would be reading it. So at a given moment of time, your active name node fs image and standby name node fs image are always in sync. They do not have to worry of copying the fs image, existing fs image, and copying the edit logs, doing the concept of checkpointing, which is nothing but merging of fs image and edit logs and making it up to date. So that has been eradicated over here with a concept. That concept is nothing but a journal node, and in that journal node my edit logs are kept. So if that edit logs are kept, whenever this active name node is writing some metadata information to the edit logs, at the same time, once it is done, this standby name node tries to read it, and this fs image is up to date. Okay, so at a given point of time, if this goes down, this comes up immediately or instantaneously. Okay, who will take care of this? This person will take care of this, and how it will take care, we will come to see slowly. Okay, so we got to know there is a in underscore use log file. Okay, so now we know the fs image, now we know the edit logs. Okay, so who is writing, who is reading, and at the same time, both my standby name node and active name node replicas of my image are in sync. Okay, so now what happens is, Zookeeper needs to maintain this name node. Okay, so how they maintain this name node? Okay, so there is a concept which that concept is known nothing but a fail over controller. Okay, so there is a concept which is nothing but my fail over controller. Okay, so with this fail over controller, Zookeeper will decide which name node is considered to be active. Okay, so there is some concept, and that concept is nothing but your fail over controller. So with this fail over controller, Zookeeper tries to keep a watch or tries to monitor all your respective name nodes. So whichever name node is active, what this Zookeeper will do, so Zookeeper tells, okay, this is the active name node, hence this in underscore use log file will be assigned to this name node. So who is doing that? Zookeeper. With which concept? By monitoring with the fail over controller act. Okay, and it is telling me that this is active, hence the in underscore use log dot file is assigned, and hence my data nodes are sending the heartbeat to my this name node, which is considered to be active because of my in underscore use log file. Okay, also at the same time, what Zookeeper does is it also has a backup. So fail over standby, or this is like fail over controller only, and this is kept on standby. Okay, so why this is kept on standby? If in a negative scenario there comes a failure at that moment of time, what could be done is this Zookeeper will tell with a fail control over mechanism to take in charge and make this standby name node as an active. We'll come to that. Okay, so as of now, Zookeeper is deciding which name nodes are up and running and how, with an assignment of a file that is in underscore use dot log file. Okay, so what are the additions? The additions are my standby name node, the additions are my journal node, the additions are my Zookeeper. Okay, so the additions are my in underscore use dot log file, the additions are my 128 MB, and the remaining are same thing. Okay, and all my data nodes are being connected to my active name node as well as standby name node. Now we will go for a negative scenario, that is a failover scenario. Okay, so let's take a scenario now. Due to some reason, this active name node goes down. Okay, so if this active name node goes down, who will come to know this active name node is down? Zookeeper will come to know, okay, my one name node is down. Instantaneously, what Zookeeper will do, immediately it will turn this, it will just make it as a standby, and immediately the standby will become active. Okay, once it becomes active, the in underscore use log will the in underscore use log file will be assigned to the standby name node, and this standby name node now will be your active name node, and hence this is your active name node. So now your data node will start sending the heartbeats to your standby name node. Okay, so what they will do, because they are connected to both the things, they will start sending the heartbeat to the active name node, which now has a in underscore use log file, and now this will not read, this will do a write. Okay, so what it will do, this will do a write. Meanwhile, what the Hadoop admin people will do, they will try to work on this failure name node, and they will try to bring up this name node. So here I do not have a manual intervention of bringing up my name node up, that is instantaneously taken over by the standby name node, which becomes as an active name node and start serving to my data nodes, wherein my processing or my failure is not into picture. Okay, so till here we are fine. So everything is like looking good, and all the things which had issues, that has been taken care of. But let's say when the Hadoop admin people were working on this failure name node, and they try to bring this active name node up. Okay, so when this active name node comes up, okay, so let's say this active name node is coming up. So by default, this will now become my standby name node. Okay, so this will be my standby with the, this will be my standby. So let me just write this also here also. So this will be my standby name node, but it is having a in underscore use dot log file also. Okay, so what Zookeeper needs to do is, Zookeeper needs to allow a fencing. What is the meaning of fencing? So Zookeeper needs to allow, what it needs to allow, it needs to allow a concept, and that concept is called fencing, which means that before fencing, let me tell you. So now if you see, once this standby name node is up, here also we are having in underscore use log file, and here also we are having in underscore use log file. Okay, so the data nodes are getting confused. Whom should I report? Which team leader should I report? Okay, so this scenario, when the two name nodes are having in underscore use log file, that scenario is called split brain scenario. What it is called? It is called split brain scenario, which means that my in underscore use log file is available with more than one name node, with one name node. Okay, more than one name node. So what is a split brain scenario? In underscore use dot log file is available with more than one name node. So to avoid this, what Zookeeper needs to do, Zookeeper needs to apply a fencing, and fencing means there should be a stoppage and removal of this in underscore use log file. So when the Hadoop admin people are bringing up the active name node which had failed earlier, and now which is my standby name node, so with the concept of fencing, they will try to apply a fencing on this name node which was earlier active. So with the fencing, this in underscore use log file will be removed. This will be made from active to standby. Okay, and once it is up, this standby name node now will start reading the data from your edge, will start reading the data from your journal nodes. Okay, so now there will be a vice versa process. So there will be no write from this. So now it will be reading it will be reading from your edit logs which are there in your journal node. Okay, so what will happen now? So this is trying to read, now this trying to write. Okay, Zookeeper is maintaining your both the name nodes with the concept of failover controller. So it is deciding which is active, which is standby, and etc. etc. Okay, so whatever the scenario was there in yesterday's, like I had a concept of single point of failure. Okay, so that single point of failure was eradicated over here. How that was eradicated? My standby name node will be becoming instantaneously active. How this will be becoming instantaneously active? Because Zookeeper is continuously monitoring all my name nodes. Okay, once it gets an immediate response of that this is failed, immediately it will hand over the responsibility to other standby name nodes. And then with the underscore in underscore use log, my processing on my data nodes, they'll be sending the heartbeat, and whatever the computation will, everything will get processing and no issues. And this concept of yesterday will be as it is. After every 1 hour, okay, after every 1 hour, these edit logs will be given to this, okay, to the secondary name node. Okay, and there will be a concept which is nothing but checkpointing, like we had yesterday. So that will be nothing but your merging of fs image plus edit logs. Okay, so after every 1 hour, your same concept will keep on working, and this standby node will always be having a backup of my fs image with the corresponding R or with the corresponding transactions. Okay, so the failure which we had yesterday, that was single point of failure, that was overcome in my Hadoop 2.x. And the second was scalability. So the scalability means grow as you need. So if you need more name nodes as my data is growing or as my request is growing, that can be done. You can just add, you can keep adding node year, and you can just scale out your cluster horizontally. Okay, so both the shortcomings of my single point of failure and scalability was eradicated in my 2.x architecture. Okay, so this is your 2.x architecture in addition to 1.x architecture of yesterday. So let's take questions on this architecture. So any questions?
So companies use either one of that architecture, right? Either
No,
Hadoop
no,
1
no, no,
or
no, no,
Hadoop
no,
2.
no, no, only 2.x. 1.x is eradicated long back.
Okay.
Mainly they are going for 2.x because the cluster should be up and running instantaneously. No doubt. See, these are like commodity computers or laptops. So there will be some scenarios wherein the failures would be coming. So hence it needs to be fault tolerant and reliable and highly available. So all the companies are implementing 2.x architecture only.
So this is the latest version.
Yes, yes. Now latest is 3.x, wherein like a pair concepts have been introduced. There is a RAID, which is like RAID is taken from Teradata concept. So there are few additions which are done, but it will take time to migrate from 2.x to 3.x. So as of now, all the organizations which are implementing Hadoop Spark projects, they will be using the same concept or architecture. So here there are whatever the failures were there, that has been just taken over, and the Hadoop block size has been increased. The replication factor is the same. So the only is like things are there. So mostly they will be tweaking you in the 2.x architecture. What is split brain scenario? What is fencing? Okay, how the journal nodes come into picture? How my reads and writes are happening in my 2.x architecture? So these will be the questions popped up in 2.x architecture.
Yeah. Hi, Saif. I have a question. So, how the data, the metadata is in sync between reactive and standby nodes?
Okay, so if you see, when the request is being sent, when the request is being sent to the from the client, okay, so when the request is being sent from the client, who is taking the request? Name node. Okay, so at the same time, this information is being written. Where it is written? To my edit logs, right? And
Yeah.
where it is, that it is in my journal node, right? So once it is, so I'll just take, because now this one is my active name node. Okay, so I'll just take back my explanation. So now when the request is being sent from your client to the active name node, okay, so this person is writing to the journal node, right? And where it is getting written? To the edit logs. So at the same time, the standby name node, what the standby name node is doing, it also has a FS image. So from this edit logs, it is trying to read instantaneously. So at the given point of time, this FS image and this FS image will have the same metadata.
If like one name node will read the data and one name node will write the data.
Yes. See, it is not writing the data. Yeah, you are right. It is writing the metadata. So if you see the transactions or the whatever the requests is which are being sent by my client, yes, this name node is just writing those information to the edit logs, where in my journal node. Okay, why it is being done? Due to some scenario, if this goes down, my other person will be able to take the charge instantaneously. Okay, so this edit logs should be updated in the FS image, or it should be available. The FS image should be available in to the updated area, so that I do not have the data failover or the metadata failover. So yes, you said right. This name node will be writing and this name node will be reading. Purely depends on the in underscore use log, who is reading and who is writing.
So, can we increase the reading name nodes also,
Yes,
or
yes, yes.
only
Scalability.
reading?
Yeah, it is. I told you na. So we can increase the name node depending on the architecture. No issues. So it's upon the architecture how we need to design it. So how many means like what name nodes. Let's say there are two. One name node is active, the other is standby. I can do that. No issues. That is a probability taken care. That's where
So
the
that can be decided at the time of
initial.
implementing the project,
Yes,
or,
yes.
or
Initial phase, very initial phase, while
yes,
deciding the architecture
based
and
on how much data we have, volume of data.
right, 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 right. Not based on data, not based on data. Ideally, it will be like, definitely your data will be taken into consideration, like how many GBs or terabytes of data will this cluster would be processing. But if you see that if you take that data into consideration at that moment of time, they will decide what the configuration of this name node will be, which means that how much RAM my name node will have and how much RAM will my data node will have. So that will come into picture. But if we just need to take the failover mechanism, so at that moment of time they will only decide which will be my active name node, which will be my standby name node. Yes, at initial stage they will be deciding that.
So all this process will run at RAM or hard disk, all the entire process.
No, this process, see, this is the this is the cluster. Okay, so this cluster will be installed at some place, correct? Because this is a on-premise.
Some hard disk, yeah.
Yeah, so say there will be some like place which we all know, like data centers. So in data centers we will be having, in few means moving ahead, we'll be seeing like rack, and there will be seeing some concepts which will coming up. So these are physically the commodity. So these are like my machines which are getting installed on some data centers and which they are stored in some racks. Okay, so these are nothing but your name nodes and your data nodes, correct? So these are nothing but your machines. Okay, so your metadata should have a good configuration. Hence they decide that this configuration, like this, the name node will have 64 gigs of RAM, because the metadata should be instantaneously available, and again the data computation will be happening to the multiple available. So the deciding factor is done on the basis of what the data will be there and how much data will be processed and what data nodes would be serving to which name node and so on. So it is not that your cluster is of 64 gig RAM or it's of something. Your individual machine, your individual name node is of 64 gig RAM, and this could be like again 30 to 32 gigs RAM. All your data nodes could be. So all depends on your uh, cluster management, what the Hadoop admin people will be doing.
Hi, Saif. I have a doubt. Like, can we have two name nodes active at the same point of a time?
At the same point of time, there will be no two active name node. So it will be only one name node will be active.
Okay, so when you scale up, it's just the data node which grows, like, right?
Yes. Data nodes which grows. Even name node we can grow, but that comes into a federation thing. So which we'll be seeing later. So if you see, there is a
Yeah.
concept of scalability of your name node. So how that name node scalability will happen, so that will be seen in the Hadoop federation.
Okay. Okay.
But that is available. So what happens is, just to give you just a brief overview. So let's say this is a name node 1. So I'm just trying to scale up my name node now. Okay, let me just remove this. So I'm just trying to scale up. So let's say this is 1 name node, 2 name node, 3 name node, 4 name node, and so on. You will be just doing the scaling up, and now there is one person comes into picture, and that person is nothing but your block pool. Okay, BLOCK and pool. I'm just writing shortcut. So this is a block pool,
Okay.
and all your data nodes will be over here.
Okay.
So now the communication will be from all the respective data nodes here was sending directly the communication to the active name node. Now they won't do that. They will send the communication to the block pool, and internally the block pool will decide to which name node it needs to represent. So let's
Okay.
say I have a organization, and in my organization I have finance, I have marketing, I have sales, and so on. So I'll be, let's say this name node will be catering to my, let's say, investment banking application. This name node will be catering to my finance application. This name node will be catering to my retail application. So my workload is getting divided. So let's say under one manager there are 5 team leaders. So one team leader is handling credit card project, other is handling savings project, other is handling fraudulent project, other is handling mortgage project, and under that individual team leaders there are so many resources. So that will be like hierarchy.
Okay.
So that is handled in federation.
Okay. Thank you. Got it. Yeah.
Yeah, I have one question.
Yeah.
Yeah, standby name node is more than one in the architecture. It's possible.
Yes, it's possible, because ideally it is one, but if it is possible to make like how someone asked, how can we scale up the name node? Yes, we can scale up the name node, and for each name node we can keep a one standby name node. We can do that. But ideally, if we do that, so it just take a cons of that scenario, which is a negative of that. So you would be just wasting your name, which you would be wasting your name node just by keeping. Let's say in my cluster I have 10 name nodes, just a small configuration I'm taking up. So I have 10 name nodes. So you'll be again doing a 10 name nodes of a backup. So 10 name nodes will be like, it just like a, you are not using them appropriately. So you can prepare 2 or 3 name nodes also as a backup, and from that you can just connect to this active name node, so they'll be just reading instantaneously. So it's all depend on the architecture configuration. But yes, to answer your question, I can scale up my standby name node also. If my applications are mission critical, like banking, investments, I do not need to have any sort of failure. Yes, I can do that.
Hi, Saif.
Yeah.
The data nodes when they send when it is sending the heartbeat.
Okay.
So one thing is it just sends the information of whether the data node is active or not, or is it send what kind of information?
Yeah. So it will be just sending the heartbeat. Yes, that I am alive, and whatever the work you have handed, I am doing that work. That's the only job of your data node to with the corresponding to your data node. But the actual computation will be happening over here, and once the computation is being done with your done, so directly your data is directly your result is sent to the client. Why? Because now once your data nodes are allocated, the client and the data node communication will be there. So these two will not be coming into picture.
Okay.
So data nodes, the name node is just to give the metadata, the resources, and all the interaction will be keeping on happening. So as to answer your question, yes, data node will only be there just to give a heartbeat to the active name node. Yes, I am alive and I'm working on the computation.
If just the data is corrupt but the data node is alive?
So let's say if let's say this block is corrupted, you are saying.
Yeah, just the data is corrupted,
Yeah,
but the data node is alive. Yeah,
so
that's
but
right.
the data node is alive. Okay, so if the data is corrupted, so with the concept of fail over, so it will just try to take the name node will try to go to the next data node, which is in sequentially or which is closer to that, and it will try to pick the same data and start the computation, because if the computation is not available.
But who will, I mean, data
Again
node
this
by
again this
itself
again
will
this
not
data
take it,
node
right?
again this data node will be able to communicate. No doubt it is sending the heartbeat, but this computation is not happening. Okay, so we are not getting the result. So if we are not getting the result, it means that computation is pending. So that computation needs to be done by some person, so that other person will come into picture.
Okay.
So, I mean, in this scenario, so let's say from the edge node, I sent a request. So first it will go to the name node, and then it will allocate the job to the data nodes.
Okay, right.
So in that scenario, if my name node went down,
Okay.
so will still the results will go to the client end, edge node.
Yes, because see, if the name node is going down, instantaneously this name node, standby name node is becoming active, right? And in use underscore log field would be assigned. So whatever the metadata which this file had, okay, the active name node, so the same metadata will be having this. So the computation will not stop, and so it will not be a problem.
Okay, with this architecture, during the middle of the job execution, if the name node failure also, it will still continue to
Right,
execute.
right, right. Why?
Uh,
Why? Because there is one concept called journal node. So the edit logs which are being written from this FS image are instantaneously being written. It's so instantaneous we cannot identify that microseconds also, you can say. It's very instantaneous. So once the it gets the information, it writes it and here also. So it's very instantaneous. So at a given moment
Okay.
of time, both your FS image always be in sync.
Okay. Got it. I mean, generally in the real time, what is the configuration or what is the RAM size of the name node?
See, it's like purely depends on the project to project. Like mine is like a banking. I'm working for a South African client for ABSA banking. So my cluster size is like of almost like it's not so big as compared to like Facebook or Walmart or Wells Fargo or the Barclays kind of thing, because the South African client is not it's not so huge. Okay, so it's just of like 124 cluster. The sizes of my cluster is of 124 nodes. It's not so big.
Okay.
Okay,
Now,
so
not the data node. I'm asking what could be the RAM size of the name node?
okay, so you're talking about the RAM size of individual name node and the data node.
No, not the data node, mainly the name node.
Name node, okay, so it's purely depends on like a 128 gigabytes of RAM which is there for my cluster.
Okay. Okay. Yeah.
So 128 gig of RAM, it's like huge but for them it's like it's okay.
Yeah.
Okay, if we are good, so we'll just try to see a 5 minutes concept and then we'll try to wind up the class. Okay, so we'll just try to understand from tomorrow onwards. We'll try to tomorrow we'll set up the machine, and from tomorrow onwards there will be no theoretical session. Yes, in Scoop and Hive a little bit theoretical session will be there, but not much theoretical sessions will be there. Now from tomorrow onwards, like everything will be hands on. So now what we'll be doing from tomorrow onwards, okay, there will be a person. So here if you see, there will be a putty. Okay, so we'll be trying to access our server with putty. So with putty, you will be entering your credentials. Okay, so what will be your credentials? The credential will be something username and password. Okay, so once you are entering your credentials, you should get connected to some place, right? And that place is nothing but edge node. Remember, someone I told you I will be telling that at a later stage. This is your edge node or your client. Okay, so what happens is once you enter your credentials, in between there is a, so now this is like this is a training environment, but in real time what we have is, in real time we have a Kerberos authentication. Kerberos authentication. Okay, and to do that we need a KTAP file. Okay, and again that these are all the things which are provided by the admin people. Okay, we need not need to worry about it. Okay, so we don't need to worry about this information. So what happens is, when we are trying to enter the credentials tomorrow, you will be getting a hands-on, so you'll come to know a little more in detail. So as of now, this will be not in picture for us, but in real time that will come into picture. So, okay, so just good to know knowledge. So with putty, we are trying to enter my username and password, and we are trying to connect to a Cloudera VM. Okay, so once we are connected to the Cloudera VM, at which location are we? We are at edge node. Okay, that place is called edge node, or it is called client. Now this edge node or client or Cloudera VM is installed on an operating system, and that operating system is mainly Linux in projects. It could be Red Hat, it could be Fedora, it could be CentOS, or it could be SUSE Linux. Anything it could be. Okay. So this environment or this edge node or client will have which flavor? It will have a Linux OS flavor. Okay, so Linux operating system would be there, right? So in your edge node, you will be able to execute your Linux related commands also. Okay, plus your HDFS commands also. Okay, when you are executing your Linux commands, okay, so these commands are getting executed on your edge node. Where they are getting? They are getting executed on your edge node, which is nothing but your local. Okay, just for identification I'm telling. And when you are executing your HDFS command, okay, they are getting executed on your cluster. Okay, so as I told you, cluster is nothing but a group of machines, group of commodity machines. Let's say these are your group of machines. Okay, so this is like a group of nodes, which is nothing but your cluster. So if you see, this is nothing but my Hadoop cluster. In that, I will be having data node, I will be having, now you know all those concepts. So I'll be having data node, I will be having name node, and I'll be having data node, and so on. Okay, so your cluster is nothing but a group of machines. Okay, so that's just, we always call cluster. So what is the cluster? Cluster is nothing but a group of machines. Okay, and that could be like your commodity cheap hardwares. Okay, so when you are executing your HDFS commands, so these are getting executed on your cluster. Okay, and this is all your part of your Cloudera VM. So your edge node and your cluster is at the same place only, so you'll not be able to understand that. Okay, so don't get confused. When we are trying to connect with the putty, I want to see my edge node and I want to see my cluster. We can see that in a web UI, but physically we'll not be able to see because that will be stored at some place in the real projects. Okay, but yes, if we are executing some Linux related commands, they are getting executed on my local, that is nothing but my edge node. When I'm executing all my HDFS related command, they are executing on my group of machines, which is part of my cluster. Okay,
Where do you execute Linux commands and where do you execute HDFS commands?
at the same place, that is nothing but my edge node.
Yeah, I mean like command line
Yes,
interface.
command line
So it's the
interface.
same
Yes,
thing.
yes, yes, same place, same
It-
place.
okay, it will be the same for
Yeah, that's what.
Linux
That's what.
commands or
Yeah, yeah, yeah.
HDFS commands.
So let me just. I did not had his email ID, but today what I will do, all the softwares which are required like Putty, WinSCP, then the Cloudera VM. So WinSCP is required to move the files from my local to my edge node. Okay, so we'll try to see all those things. And Putty is to connect to your Cloudera VM. So in real time also, when we log into a machine, okay, via Citrix or let's say via VDI or via say RDP. So once we are into the arena, okay, so there will be a Putty. So with that putty, we'll be trying to connect to our servers. Okay, so same way we'll try to follow the process over here. So this will be your edge node. At the same place, you will be firing your Linux commands. Okay, at the same place, you will be firing your edge node commands, HDFS commands. The only difference is whatever the Linux commands would be there, so that would be local. Okay, local to your Linux operating system. There is a typo error. Okay, and whatever the HDFS commands are there, that will be working on your cluster. That's only the background we need to understand. Okay, but the
How about Zookeeper those things?
Zookeeper. So see, this is like a training environment. The Cloudera VM is like a training VM which is being there. So we will be having those services, but we will not be able to monitor that because this is like a standalone cluster. It's a single node cluster. So we
In
do not
real
have.
time,
Yeah, in real time we have a zookeeper. We have the Uzi for workflow schedulings, but as a developer we don't need to get concerned about it. They are like admin people. We are just worried about the development. We are just worried about the scheduling of the jobs. We are just worried about the optimizing of the jobs. So our day will go like this only. Will not. So whenever we,
performance too.
yeah, whenever we get the failure, like let's say my Hadoop goes in safe mode, I will not be doing anything. I will be just sending a mail to the Hadoop admin team. In my case, that is Bagel team, which is Barclays Africa Group Limited. So we are working for the APSA client. So I'll be just sending a mail to them, and I'll be going into the coffee break, and I'll be coming back after half an hour or 1 hour. That's what I do. So it's their work.
So in this VM, all the data node, name nodes will be in the same machine?
Yes, here it
Same
will
machine?
be, here it will be available in the same machine. But in the real projects, your data nodes, because see, if one rack goes down, I'll come back, I have not explained that rack awareness concept, but I'll be explaining. Let's say if one data node goes down, I need to have my information available at other place also. Otherwise, my Hadoop's feature will be not achieved. That is failover, reliable, and high availability. So yes, the same block will be available at different data nodes in different racks.
Yeah, like why I'm asking because in Linux, so can we have like a separate
What happens is, let me stop